Okay, I hope you can still see me with all of these numbers up here, but I've added a few more rows, and we want to continue talking about how the universe developed. So now we have gone from 380,000 years after the Big Bang to 100 million years after the Big Bang. The temperature has gone down from 3,000 Kelvin to 100 Kelvin, and then the size of the universe has gone up to 10 to the 50th meters across. So not much is changing about the composition of the universe. So from now on, the universe is going to consist of atoms and stuff. Okay, but notice now you have your first globular clusters of stars. So these are going to be the population 2 type stars are beginning to form. So immense gas clouds composed of hydrogen gas. The gas clouds are collapsing and turning into these globular clusters, and you have these population 2 type stars which are going to be composed just of hydrogen and helium, because that's what the universe is composed of at this point. And so now you have your first stars, and these first stars begin to congregate around areas of dark matter. So remember, dark matter causes gravity, and so the areas that were concentrated in more dark matter meant they were concentrated more in mass. Mass causes gravity. It attracted these clouds, these globular cluster things. And then the globular clusters began to collide to form the first galaxies. And then the galaxies began to clump together to make the first clusters of galaxies and super clusters of galaxies. So all of this is occurring about 100 million years after the Big Bang. Okay, now we're going to skip to approximately 9.2 billion years after the Big Bang. And this is when our solar system begins to form. The temperature has now dropped to 10 Kelvin, and the size of the universe has gone up to 10 to the 51 meters across. But do you remember dark energy? And at the very beginning of the lecture, I said something about how the force of gravity had the regular force of gravity, the big G m1 m2 divided by r squared, which was negative, and it was attractive. And then I said that there could be another part to the force of gravity that was positive, and it was the dark energy, and it would push things away. And I said that as long as the size of the universe was small, this term was dominant. But as the universe gets bigger and bigger, this term over here gets larger and larger. So they think that also during this time period, about the same time as the Earth was being born, dark energy became more dominant than regular gravity. And so that's probably just a fluke that happened, but it did. So that's when dark energy starts to dominate gravity. And we'll talk more about how the universe is accelerating as it is expanding in our next lesson. Okay, now we're going to fast forward to approximately 14 billion years after the Big Bang. The temperature is now down to 3 Kelvin, and the size of the universe is up to 10 to the 51 meters across. And so that's today. So that is the current size, the current temperature, and we think that the Big Bang occurred approximately 13.8 billion years ago. And so today, the universe consists of all sorts of different kinds of atoms, and then it also consists of dark matter, and it also consists of dark energy. Okay, so there you go. So when we return, oh, and then here is the summary of what we have just done. So beginning all the way up at the top of the chart, I believe, is the birth of the universe, 10 to the negative 43rd seconds. And then as you go down on the chart, you are going into modern history. So if you can read that, just blow up the picture so that you can read everything, and that's a summary of everything we talked about. Now, out of all of these numbers here, what do you need to know for purposes of the exam? And that is this thing right here. So as long as you remember that approximately 100,000 years after the Big Bang was when the first atoms formed. And then that's what produced the cosmic microwave background radiation. So those radio waves that Bell Laboratory discovered back in 1963, okay, that was the cosmic microwave background radiation, and it originated as light approximately 100,000 years after the Big Bang. Now, really, it's 380,000, but 100,000 is good enough for me. So out of all of this information, that's the only number that you should need to know for purposes of the exam. We're done. So if you will join me for our next segment, we'll take a quiz over what you have just learned.